they don't miss this meet. We'll wait for a few more minutes. Okay, then let's start the session. Hi everyone, myself Harsha Johnny. I am a TPG Kerala chapter lead. So, welcome to the second session of the Phoenix Skill Kerala the Solidity Bootcamp. A warm welcome to each one of you. So, for those who are new to the session, let me introduce what TPG is. The Phoenix Skill is a Web3 community whose mission is to create a diverse and inclusive Web3 ecosystem, and our vision is to create opportunities for women, binary, and non binary individuals to take up projects and leadership opportunities in the Web3 space. And in the past few months, we've conducted so many successful events which have helped many individuals in their Web3 journey. For getting updates on the upcoming events, let me say there are so many exciting events waiting for you. For getting updates on those events, check out the link provided in the comment section, or you may scan the QR code given in the screen. Ashwin, can you change the slide? Yeah, you may share this QR. You may scan this QR code. Okay, so once again, welcome all to the second session. Handing over to Darshana. She'll be taking the session today. Okay.
Hello, everyone. Thank you, Harsha. So, hi, everyone. I'm Darshana, and I have been a part of TPG. I've been volunteering for TPG for more than a year now, and I'm very thankful for this opportunity to do this session where I'm going over an introduction to Solidity. So, why don't I go ahead and share my screen? Harsha, I don't think I can share my screen.
Yeah.
I think now you can.
Yep. Is my screen visible?
Yeah.
Right. Great. So, like I said, I'm thankful for this opportunity, and I will be going over an introduction to Solidity in this week two of the Solidity bootcamp. And so, let me just go over what I'm going to go over in this presentation. So, in this presentation, I will basically give an overview of the Solidity programming language, and that will in general cover various topics like um, the Solidity basics. I will go over what the Solidity source code generally looks like, the layout, and other various terms that you will generally come across whenever you are reading anything related to blockchain or anything Web3. So you'll come across terms like gas, operators, variables and functions, and value types and the control flow of the Solidity programming language. So I'll just be going over some of these terms and basics of Solidity. Also, this is an interactive session, so you guys can stop me anytime if you have any doubts. You can also like unmute yourself and ask any questions. I will be very happy to answer them. So let me just start off by telling what Solidity is. So what exactly is Solidity? Now, Solidity is a high-level programming language that is specifically designed to write smart contracts on blockchain platforms. And its primary purpose is to enable the creation of self-executing, tamper-proof, and trustless smart contracts. Now, what do I mean by self-executing, tamper-proof, and trustless? So basically, Solidity and any programming language that is built on blockchain, it allows the developers to define the rules and logic of a contract, which they then deploy to this blockchain. And it ensures the automation and transparency of the smart contract. So they don't need to make any changes to the code. They don't need to sit there and redeploy it again whenever they are making any changes. All of that will be taken care of by the blockchain network itself. And there is also transparency, obviously, because we are removing the need for any intermediary. So that is one of the main needs for the Solidity programming language. And now, what is a blockchain? So, as I already know, as all of you might have heard anywhere else, a blockchain is basically a distributed and a decentralized digital ledger that records transactions across a network of computers that are usually called nodes. And these transactions are grouped into blocks and then they are added to the chain in chronological order. So once you make the first block, the second block will be added after the first block. And the order is chronological, which is self-explanatory. And one of the main features of using blockchain and Web3 is that there is immutability and there is transparency. These are the core characteristics of any blockchain. Now, let's go over the layout of a basic Solidity smart contract. So you may have seen smart contracts anywhere. You can just Google them. You will go over basic code that looks like this. And this is a very basic layout for a smart contract that is written in Solidity. So you may already know that whenever you have any file, let's say you have a document file, it has the extension .doc. Now, any PDF files will have the extension .pdf, right? And similarly, any source code, any files that are written in Solidity, they must have the extension .sol for the compiler to recognize that it is a Solidity file. It's a Solidity smart contract, and for it to compile properly. So any smart contract that you see anywhere, it usually begins with this first line. You can see over here, pragma solidity, this symbol followed by 0.8.0. Now, what it basically means is it um, it begins with the pragma solidity and it follows this version number that needs to be used by the compiler to compile it efficiently. Now, why is this usually happening? So, Solidity is it's a growing language. It generally is being like developers are working on it endlessly, and there are new versions of Solidity coming out every single day. Like one single day can break or make a new version. So when you mention this sort of version that you basically start off in the code mentioning the version of the Solidity so that the compiler knows which version of the solidity it needs to compile. And then you can see that the rest of the code, it consists of various things like it contains contracts. You can see there's a contract keyword. There are libraries that sometimes need to be used. There are interfaces, and these are basically the fundamental blocks of the Solidity program. Now, what is a contract? This contract is what contains the main logic of any smart contract. And this contract defines the behavior and state of the smart contract. Now, it is usually defined or declared by using this contract keyword, and it is followed by the name of the contract. So here, the contract keyword is used and followed by the name, which is basically my contract, and then followed by the curly braces inside which you have the body of the contract. So this contract, like I mentioned, it defines the rule and behavior of the smart contract that is deployed on the blockchain. And they can have state variables that usually store data, and they can also have functions. And what these functions do is they interact with the state that you usually have defined earlier and perform certain actions that you need to perform whenever you want to compile the code. So you can see the state variables that are declared here, and you can see the function, right? Now, I will move on to showing you what um, a remix editor is. Right. So you guys might have heard about IDEs, integrated development environments. I hope you guys are familiar with that. So if not, I can let you know what IDEs basically are. So IDEs are where you write code, and it has a built-in compiler where the compiler will be compiling the code that you write and run it, right? So similar, we have different types of IDEs, and there are also like IDEs for that can be used for various different languages. Now, for Solidity, we usually use Remix, and we obviously have other ones, but for beginners, I think you can just start with Remix. And Remix is basically a browser-based IDE in the sense you don't need to install anything. As you can see over here, I just did remix.ethereum.org, and um, I have my own I have my own Remix IDE open in my browser. So I don't need to install anything. You can just go to Google, you can click on a new tab, and you can just copy paste remix.ethereum.org. And so, like I said, this is an integrated development environment that is made specifically for Web3 languages. And here you can see in the top left corner, there is the home button. And this is the home screen. Like you can see, there are various resources that we can use to learn about Remix, how to use Remix. And if you are very new to Solidity or anything, you can, like there are various links that are mentioned here. You can go over the basics of how to use an IDE, and there's an intro to Solidity, how to deploy the file that you have, etc. Now you can also see that you can also see in the left there are other icons like this one. It shows the files that are present. So over here there is a server.sol file that is already there. This this icon will help in creating a new file. I hope you can see my mouse that is hovering. So like if you click this one, you can create a new file. Let's say example1.sol. Like I mentioned, the .sol, the suffix is very important to let them know that it's a Solidity file. Now, once you can do that, once you've done that, okay, I'm not sure what is happening. Right. So you can see that I just created a new file called example1.sol. And now we just start off with, let's say, pragma, you know, Okay, let's just use Solidity 0.8.0. So what we've basically done is we have asked Pragma Solidity to use the version 0.8.0. And then we go over, let's say we just do, you have a constructor, you have a function, etc. So this is how you start writing any Solidity file. And in here, you can search, let's say you have a lot of files, you want to search specific keywords, you can do that over here. The IDE helps with a lot of things. And here is what is how you are going to compile any file that you have. So in the left, you can see that it's called Solidity compiler. Let's say you don't have a Solidity file. You have written your smart contract in any other language. So you can change that as like however you have. And then there are multiple EVM versions also. And now Now I have only one file that can be compiled over here. I just created looping.sol. So there is only one option that is mentioned here, like you can compile looping.sol. And what it basically does is it has compiled, um, like if you can see, this was the latest one. Let's say if you guys haven't seen it, I can just compile it again. Right. So this file has been compiled. And how do you know that this file has been compiled? You can see the green arrow to the left. Like usually you don't see that arrow whenever you have any errors or warnings that are mentioned in the file. Like let's say you remove this keyword and let's say you try compiling it. You can see that there is one warning that is mentioned. So you can see there is compilation successful with one warning. If you can see it on the left side. And then the warning is also mentioned. Like it shows that the function state mutability can be restricted only to pure. So you need to mention, okay, so it needs to be pure, and then you try compiling it again. Now you can see that the compilation is done successfully without any warnings or errors, and then there's a green tick mark on the left side. Now that is the compilation part. And now to the left, to the next icon, you have the deploying and running transactions. Now, before we go over to the deploying part, let's just look over the other variables that are there. So you can see over here that you have the environment variable. And what it basically means is um, like these are different environments that are used to deploy the Solidity smart contract that we have. So if you know what VM is, a VM is a virtual machine. And what it basically means is you have the smart contract that you have over here, and you have it written, you have the file and everything. Now, for it to be deployed on a real blockchain, this virtual machine, let's say this Remix VM that is like this one is probably in Shanghai. So this virtual machine that was made in Shanghai, it basically is deploying the file that you have written over here into a blockchain in the virtual machine that is run over there. So you have this all in hand in your IDE, like in your fingertips, and you can just deploy it easily. You don't need to go over the tedious process of deploying it in for real. Like for example, it also mentioned gas limit. You can see that there are various accounts that are there. So usually, like you might already know that you need different addresses and accounts to interact with other files or basically if you are to be in the blockchain you need an address, you need an account. And what this remix id basically does is it has a set of accounts that you can use while you are deploying whatever file that you want to deploy. Obviously this gas limit is not like it's not being deployed into the real blockchain. This is just like a dummy thing, but you are able to deploy it and see how it will be deployed if it is to be deployed in a real blockchain. And this value function over here, like let's say now it's zero over here. But there are some functions that will require you to input some value, like any functions that will require you to give a value and that will take some value from the user. You can give some of those values over here. But since this function, like this is one example that I've taken. This is a looping example, which I will go over in the later part of the presentation. This does not necessarily take an user input value, but let's say I just try giving a value and then I try deploying it. You can see that there is an error, and that is basically because there is no requirement or there is no user input that is used, but you have given a user input already. Now, with the value 0, let's try deploying it again. And you can see that this deployment is successful. And it gives like a bunch of basic information like the transaction is mined and execution is done, succeeded. And you can see the transaction hash, you can see the block hash. And what this block hash basically is, this block hash is refers to the block in which the data that you've sent is being transferred or it's being given. You remember when I said blockchain is basically made of different blocks where all of them are just combined. So this is the hash that is referring to that certain block that has the information. Now, this is the block number. This is the contract address. This is your address from which you are, basically deploying this smart contract. So this address will be very similar to this one. Let's say you use a different account. This contract address or this from address will be changing. If you can see over here, 0x5B38, ending with a C4, this is what is used over here. Let's say you change the account and then you try to deploy. Now there is a new deployment transaction, and you can see that there is a different from address, and it is similar to the CB21. So it mentions which um, address you are trying to deploy the transaction, which is the block number, the hash of the block number, and it gives you all the details that are required to show that your transaction is done and the deployment is successful. So this is how you basically deploy your smart contract in Remix IDE. So these are the tools that you'll generally use. And this IPFS, maybe it's an advanced thing. And there are also transactions that are recorded. So once you have done certain transactions, these will be mentioned over here that you have deployed so and so contracts. And you can also choose which type of smart contract that you want to compile. Because I have only one looping.sol over here, or otherwise you will be able to choose which contract you want to compile using the like push down button from here, right? So this is like a very basic overview of what Remix is and how you will be able to like deploy your smart contracts, like whatever smart contracts that you write, like example was by using Remix editor, you don't have the problem of finding a real blockchain to deploy a smart contract, and you are just able to see what are the effects of your smart contract without having to deploy it in a real blockchain, right? So I just wanted to give you a very big, like a small overview of the Remix ID. Now, coming to variables in Solidity programming language. Now, I think most of you would definitely know what a variable is. Like we might have seen code, the general code in general, C++, Python, or something. And all of these programming languages, in general, they have variables. And what are variables basically? They are entities that store and manage data within smart contracts here in Solidity. And they play a very important role in maintaining the state of the contract and to help with any interactions that come with it. So now Solidity supports various data types for variables. There are like primary data types like integers, booleans, addresses, and there are also other data types that you can define. And these are called user-defined data types called structs. So we will go over them in the later part of the presentation today. Now, now that you know what variables are, you will be coming across a wide variety of them. So you need to know that that there are two main types of variables. There are state variables and there are local variables. And how are they different? They are different in how they have their scope. So by scope, what I mean is in Solidity, variables can have different scopes, and state variables are basically declared at the contract level and they have a storage location. So let's say you have a variable that you are mentioning at the start of the smart contract. It's not enclosed within a function. Now you are able to use the variable, declare it, or like use the variable that you've declared in the beginning anywhere else in the rest of the smart contract. Now this is the use of a state variable. Now local variables are only declared within functions. Let's say you have a specific function. We have already mentioned a function over here. You have a function over here, like here, and let's say you defined a new variable within the function. This variable that is within the function would not have any value outside of this function. You cannot use the variable that you have defined inside anywhere outside the function. And that is what is a local variable. They have a shorter lifetime and they are only available within the execution context of the function, whereas the state variables can be accessed anywhere inside the function. So now that we know what different variables are and how different variables are generally used within the smart contract, you can see how to declare a variable. Like I've mentioned, before you are going to use any variable, you need to declare them. You need to tell the compiler that this variable that you've mentioned is so and so, is of so and so data type and has a so and so name. And how do you do that? Again, you have, you know, it is declared by the variable type followed by the variable name. And public is basically, it can be either public or private depending on like who can access the smart contract. So that's another thing. But generally, it starts off with the variable type followed by the variable name. This is this is the usual syntax that is followed by anyone wanting to declare a variable. So here you can see that there is a UN256 public my number, and what it means is you are declaring a variable that is called my number, and it is of the data type UN256. Again, you have another variable declaration here called address public owner. The name of the variable is owner, and the data type that owner is basically is of address. So this is how you declare any variable inside a smart contract. Now, we can see that there are different types of data types. Like here itself, I can see that I just told you two different types of data types, new data types. Like what is UN256 and what is address, right? So now we can start seeing what are the different types of data types that are generally used. Now, why do we actually have different types of data types? Why not just like use one integer, one boolean, and then that's it? Like why do we even need so many things? Why, like in general, all of them are characters. Why do you need so many different types of data types? Now, why in general we have different types of data types is because these data types are responsible for certain behavior of the variables. Like there are certain types that you can do with unsigned integers that you can't do with a Boolean. Like you can't do with any address. So by mentioning the different types of data types, you mention the different things that the specific data type, or the variable with the data type can do. That is one reason why you have specific data types. And also because each data type, like let's say you declare a data type or you use a data type in any smart contract, each data type will have a certain gas fees that is associated with it once once that specific piece of code is run or compiled. Now, I will go over later why gas fees needs to be reduced and what gas it actually is. But in general, it is useful for you or anyone who's writing Solidity to use the correct type of data type so that they don't waste gas fees or they don't incur an extra gas fee whenever they use any data type. Now, we will go over some basic data types that are generally used in Solidity, and these are called primitive data types because they are already defined. So one of the first one is UN, which is basically an unsigned integer. And uint represents non-negative whole numbers. So that can be uint 8, there is uint 16, and it goes on till uint 256, basically multiples of 8. And why is this multiples of 8? It's basically because you like think of it as bytes. You are storing the variables as bytes in memory location. So that is why they are multiples of 8. Now, uint256 is the most commonly used type. And where is uint data type generally used? It is used for quantities, token balances, and any numerical calculations wherever negative values are not needed. So in the name itself, you can see that it's unsigned, only positive ones. Let's say you are dealing with money exchange in any smart contract. You're writing a smart contract where you are updating the balance in your bank account. That's just an example that I'm. So you will probably use a uint data type to represent the variable that will take care of the bank balance that you have. Or let's say in this case, the balance in your specific Ethereum address. So you will use the uint data type for that. Now, the next one is an int data type, which is basically a signed integer, and it represents both positive and negative whole numbers. Uh, as you can see, like other than unsigned, I'm sorry, compared to unsigned, this is signed, so it will include both positive and negative integers. And again, int can also be of the form int 8, int 16, in 32 into until in 256. Again, multiples of 8, and in 256 is the most commonly used data type. And this is basically used whenever you have values that require both positive and negative. So I cannot think of use cases right now, but whenever you need both positive and negative ones, you will basically use an int or a signed integer. Now, Boolean data type, as the name suggests, it can only represent true or false, and it's used whenever you have condition or conditional statements, and whenever you need only two values for any variable. Like you only need to know whether a value is true or whether a value is false. Now, you can use it whenever there is decision making that is involved in any smart contract. So that is when you use Boolean data type. And the last type of primitive data type that is generally used is the Ethereum address, or generally known as address, but it represents an Ethereum address, which is basically like a 20-byte identifier. In the example that is given over here, maybe you can see the 0x123456, right? So this is how an Ethereum address basically looks like, except, instead of 1234 and all, it'll have a mix of numbers and alphabets, but this is how an Ethereum address looks like. And whenever, let's say you are like doing any transaction, or basically anything that you do in a blockchain, you will require your Ethereum address. And this address primitive data type will help in storing the, Ethereum address that you are using. So like you can find examples of data types that I just mentioned. There is uint256, there is int256, and this is how you declare and assign a value to the variable that is there in the data type. I have probably gone forward, but this is how you basically use primitive data types. Now that I have mentioned what data types are, you have seen most of the terms that are going to be seen in smart contracts. Like you basically know what data types are and how you're declaring all this. So now that you know that, you need to know other terms that are generally used whenever you go into Web3, or like you just will be hearing about these terms everywhere. So let's just talk about what constants, ether, and gas basically are. So constants in Solidity, also like other programming languages, they are basically declared using the constant of view modifier, and they represent values that do not change during, the whole life cycle of the smart contract. Like let's say the value 5, um, you know, like let's say you have a variable that you initialize and then you declare, and then you initialize its value to 5. Now let's say in the next sentence, you maybe change the value of the variable to let's say 10. Then the value of the variable will be changed. But whenever you use constants in Solidity or in any programming languages, the value of the constant will not be changing anywhere, inside the contract or during the life cycle of the contract. And these are used for storing configuration values, constants, and basically used to store data. And now coming to one of the most important terms that you will probably hear everywhere, Ether. Now, Ether is the native cryptocurrency of the Ethereum blockchain. By cryptocurrency, I basically mean like the currency of Ethereum blockchain, like how you have money, right? Money is a currency. You have different types of currencies, like you can have rupees, you can have US dollars, Canadian dollars, Australian dollars, etc. Now, Ether is basically the cryptocurrency of the Ethereum blockchain. Now, again, like how we have for money, we have different types of currencies. For Ethereum blockchain, now that we know that Ether is the cryptocurrency, there are different you know, units that are used to that are used to describe ether. Let's say there is V and then there is V, there is V, etc. Now V is the smallest unit of ether, where one ether is 10 to the power 18 V. Now we can see how we can see through the magnitude of ether value in terms of V. Like you can see how just one ether is equal to 10 to the power of 18 V. That how every single transaction will be a minute quantity of ether in gas. So whenever you, let's say, deploy a transaction, whenever you deploy a smart contract, there will be a gas fee incurred, which I have mentioned before. And this will be in minute quantities of ether. And that is because ether is such a big value that, you know, we need a smaller unit called V to be able to use it in, we don't generally want to use it in 10 to the power of minus whenever we are dealing with day-to-day transactions. So that is why we have different units that are used like V. And Ether is used for transactions and to pay for gas whenever we are executing any smart contracts. Now, what is gas? I have talked about gas so much whenever I've been, going through various different terms. Now, gas in Solidity, it basically represents the computational work that is required to execute the operations and functions within smart contracts. Now, we have written smart contracts. And once we have written smart contracts, we are, like compiling it, we are deploying it in a blockchain, we are deploying it in a remix ID, you know, we are going to a hard hat website, we are, making our own account and we're deploying it there. But all of this requires, some sort of energy, like something is being required for all of these transactions to take place. Now, this is where gas fees come into picture. And these gas fees are basically collected by miners that, go over these transactions in blocks, and they basically find out the hash value. This is where gas fees come into picture. Now, this gas fees, like I've already mentioned, this all of this happens whenever a code is compiled or executed, and every single line of code that is executed by the compiler will incur some sort of gas fees. So let's say you have a for loop, and inside the for loop you are compiling a statement or executing a statement, let's say 100 times, like for int I equals 1 till I less than 100 and I plus plus. You're doing it 100 times. So the gas fees that will be incurred for this smart contract compared to a simple smart contract that will just, compile the one single line of statement is almost 100 times. So now you can see how you need to be able to write, optimized code. You need to be using specific data types that, are required correctly. You need to be using the proper types of data types, etc. This is how you will be able to reduce gas fees and gas costs whenever you're executing a smart contract. And also there are different types of gas fees that will be incurred. It also depends a lot on the blockchain that you're deploying it in. So, like Bitcoin is a type of blockchain. There is Ethereum. So all of these types of blockchains will incur different types of gas fees, which you by doing a simple Google search, you can understand how there are different types of gas costs, etc. And but basically by minimizing the use of loops or like basically understanding how you can optimize your code, you can optimize the gas fees that are input with each smart contract execution. Now, I have probably talked a lot, but you can there are two fun exercises for everyone attending the session to, you can probably take a screenshot or you can come back to the recording later. But you can do this one exercise where, we have gone over what a contract is. Now that, we know the theory behind everything, everyone can just write a simple smart contract where what you basically do is you declare four different types of variables. We have already mentioned the four different types of variables that are there. Primary data types, you can use those data types to, you know, declare different types of variables. You can write functions to, manipulate values in these variables, and you can return the value of the variable using different sort of functions and variables. If that is an exercise that everyone can do later on. Now, there's another fun exercise that can be done. Since we have mentioned so much about Ether, the gas values, the gas costs and all, now that you know Ether is the cryptocurrency, you see that there are different units that are used whenever you're using Ether. There is ETH, which is basically Ether. There is Wei, then there is Gray. And like I've already mentioned, one Ether is 10 to the power 18 Wei. So I can probably make it a little bit more interactive. Anyone can, you know, unmute their mic and just tell how much ether is one Wei. We know that one ether is 10 to the power 18 Wei. By a simple mathematical calculation, anyone can just say how much ether is one Wei. Or you can also put it in the chat if that's possible. Hello.
Yeah, Darshana, you are audible.
Okay. Right. I cannot see anyone unmuting their mic.
How much
Okay.
is one ETH in Wei? Oh, was that your question?
Yeah, I was asking, like I've mentioned here already, one ether is 10 to the power 18 Wei. And I was asking them how much one Wei is in terms of ether. So it's just,
minus 18.
yes, exactly. So one Wei is 10 to the power minus 18. And I'm probably ruining the exercise for everyone, but one Wei is 10 to the power of minus 9 ether. So I'm just mentioning different types of units that are used to whenever you make any transactions. So Wei and Gray are some of the most commonly used units. Right. Okay, so we have gone over how different variables are used in a smart contract, how we start writing a smart contract, what are the different terms that are generally used, um, what is the contract keyword, what are variables, what are data types, and what is a function. We have done almost everything. But let us now start talking about how we are going to write code in Solidity. So whenever we are going to write code, we are going to be using different types of, uh, you know, uh, we are going to be using different types of code using languages like arrays. You will be using arrays, and you'll be using self-defined, user-defined structures. Structs are basically user-defined data types. We have seen primary data types. Now we'll be creating our own data types. So now we'll go over what arrays are in Solidity. Now, arrays are basically data structures that allow you to store and manage multiple values of the same data type in a single variable. We might already know what arrays are whenever we have, used different programming languages. It's how you basically use in C++ or Python. So in Solidity, arrays are basically the same. They are used to store and manage multiple values of the same data type. And they are also used for managing collections of data. Now over here, you can see U in 256 followed by the square bracket inside of 5. This is how you declare the array, right? Now, Solidity supports various types of arrays. There are two main types of arrays. There is a dynamic array and there are fixed size arrays. Now, dynamic arrays are arrays that can change in size during contract execution. So, let's say you have just defined arrays where you did not mention the number of elements that will be used in the array. That is an example of a dynamic array. And because you have not mentioned the size, you can be able to change the size during the execution of the contract. Like you can mention uh, in the middle of the execution where whenever you are, appending any new element to the array, the size of the array will be changing. Whereas fixed size arrays are not like that because you will be mentioning the size of the arrays in the beginning itself. So over here, this is an example of a fixed size array and this is an example of a dynamic array, right? So here, because we have mentioned 5 inside the square bracket, it basically means that you can only store 5 integers. So U in 256 will be that particular array will be able to the fixed numbers array will be able to only store 5 integers. Now, declaration of arrays in Solidity are basically similar to how you declare other, variables. So declaring. You start off with mentioning the different data type that you're using. Like here, there is an address, and here there is an UN256. So this is, you first start with mentioning the different data type that you're using, followed by the name of the array that you are going to be using. And here, because number of, uh, you haven't mentioned the number of elements, it's going to be a dynamic array, whereas this is a fixed type one. Now, you can also add, remove, and modify elements to arrays, which is why we are using arrays for. So here you can see that there are different functions that are, mentioned in this example. So in the first function over here, we have the function add user, and this add user takes in the address new user as it takes an address new user as input, and it will do the following result. Like it will push the new user input value that you're giving to the user's dynamic array. This is how you're going to change the value of the dynamic array. And to change any element of the fixed size array, you have another function example over here. You have a modified fixed number, and it takes in two input values, like it takes in the index and it also takes a new value. And there are certain conditions that are mentioned over here, which we will again go over in the different types of statements. You have a required condition. So you can see that only when this condition is being met, the following, next set of statements will be compiled. So once this thing is mentioned, this condition is met, you can see that the new value input that you've given will be appended to the fixed numbers array, which is a fixed size array. So this is how you are able to change the value of any element in the fixed numbers array by mentioning the index and the new value that you wanted to be appended to. Now, there are functions that can add and remove elements. So that we have just seen right now, we have added elements in both, dynamic and fixed size arrays. But now we can get the count of users in the dynamic array as well. So here you have another function where you mentioned the name of the function is get user count. You are giving in the you are not giving in any input, but you are getting the length of the user's value. So users dot length will give you the users array, the length of the users array. And again, we have the user's address, and return users in a square bracket index will give you the address of the users by index. Like whenever you mention, let's say you want the address of users, the first user, then you'll be getting the address of the first user once you give the index as one. So this is how you are able to retrieve data, you are able to add data, remove data, and even modify elements within arrays. Now, before we go on to structs, I would like to mention how when are usually arrays used in whenever you're writing Solidity. So let's say you want to specify a list of users, you want to specify users and their addresses. Like, this example itself is a very good example how we uh, we require one data type that is used to store users. We also require a data type that is used to store integers. And let's say we have another function that is, combining both of them. So this is a very good example of using users and addresses and data that is associated with users and addresses. Also, you can maintain records of transactions this way. You know how I have mentioned that blockchain in itself is different types of transactions encoded in blocks and which are then added chronologically. So it's an example of array, like in the broader sense. So let's say you want to use transactions in any smart contract, you can use different types of arrays that we just mentioned over here. And you can also use different token balances. You can assign different tokens to users. And once, let's say they have used a certain amount of money from their addresses, you can assign that value of money to their address using arrays and like mention what values they have, etc. So this is basically where arrays are generally used in Solidity. Now, coming to structs, what exactly are structs? I've mentioned structs before when I was mentioning data types and when I was mentioning variables as well. Now, structs are basically user-defined data structures that allow you to group multiple variables of different data types into this one singular and composite data type. So in the primary data types that I have mentioned before, I have mentioned, like here, I mentioned an unsigned integer, I have mentioned a signed integer, I mentioned Boolean, but you can see that these are very simple. Like you cannot give multiple, let's say you want to define a person. But if you're using only primitive data type to define a person, you will only, let's say, use something like an address. You will just give them their Ethereum address. But then let's say you want to tell that each and every person that you're defining, like each of them has, let's say, one card and like 2 bytes and one cycle. And you need different, data types. You need your own customized data type. So now the primitive data types cannot be used to solve your problem. You can, resolve to use structs in Solidity. And so, like I said, these are basically user-defined data types, and they are declared using the struct keyword over here. So you can see that there is a struct person, there is a string name, and then there is a UN456H. Like I mentioned, you start with a contract. There is a struct example contract, and then you define a struct called over here, and the name of the struct is person, and each person has these two types that are associated with it. So let's say person one can have their own name one, their own age one. Person two can have their own name and they have their own age. So this is how you are able to define a structure. Like you just use the struct keyword and then the name of the keyword followed by the curly braces. And inside the braces, you use the different types of data types that you want. So let's say instead of string, if you want something else, if you don't want a string, you want a age, you want another address, you want their own boolean, whether they are a male or a female, etc. You can make your own user-defined structure. And this is how you define them or declare them. Now, now to initialize these structures, you initialize them in either constructors or functions. And I may not have mentioned it before, but constructors are basically like functions, with the exception of they do have some different stuff that are only done by constructors. But in general, they are like functions, except that they are only executed once in a whole smart contract. So that is one special part of constructor. And over here, you can see that, right. So over here, you can see that you have a person struct, you have a string name and event associated with the struct. And over here, in the constructor, you are initializing a person. You're initializing a name for real. Like the name here is Alice. The person name is Alice and their age is 30. So the Alice is the string that is going to be, given to the struct, and 30 will be the integer that is given. Now, whenever, let's say you have to update the age of, the name, you have to update the age of Alice. That is one certain person. You can just call the name of the struct followed by dot, and then the type that you want to update. So over here, Alice is there. You are initializing this particular struct. You are initializing this person. And then you are calling the age type that you want to update. And then you are mentioning the new age. Or you are mentioning, let's say, instead of new age, you want to make it 20. So you're just mentioning 20. And now, whenever you're using the word Alice anywhere else, and you are asked to, retrieve the like value of the age type of the person, Alice, then you will get 20 instead of 30. And this is how the information of the person Alice will be changed. So this is just a very basic example. You can, again, instead of age, you can start with name, and then instead of a integer value, you can give a string value where, the name itself will be changed, etc. So that is how you will be able to change different data inside structs. Now, coming to mapping and Solidity, we have gone over main types of statements that will be used, like there will be arrays that will be used, there will be different types of data types, there will be structs, you can define your own structs. Now we will go over how we are going to manipulate the code to make it do whatever we want. And this is one basic example where mapping comes into play.
Darshana, excuse me.
Yes.
If you want to take a break, you may do so. Drink something.
No, that's fine.
That's
I
fine.
think.
Okay.
Yeah.
Sure. Continue.
Um, right. So, like I've mentioned, we have gone over different data types. We have, talked about arrays. We have gone over data types, structs, and making your own stuff, changing the value of different stuffs, etc. Now we are going to see how we are going to change the code to, get whatever result you want from the smart contract that you're writing. So that is where mapping is one sort of type that you can basically use whenever you're writing code. So mapping is again like a key value data structure. And what it basically does is there can be unique keys, and these keys will be associated with some values. So again like a data structure, you have the same. You are defining mapping thing. You are defining the key and then the value that is being given. And then you are also able to call the data type, and you are able to change the value of everything, etc. It's basically how you use any different, data type. So here you can see that mappings are basically declared using the mapping keyword. This is how any mapping keyword would start. You have the keyword mapping followed by, the key and the value data types. So over here you have the address. u into 56. So yes, the address key will take the value u into 56. Like every single key value will be taking a different value. Now, uh, now again, like different data types, you can use this mapping that you have initialized over here in different areas. You can use it on a kind of function. Like in constructor, it's where it's usually initialized. And then in function, you can change the values of the mapping that you've initially defined. So over here, you have initialized the name of the mapping to be balances. You have the message dot standard equals 1000 ether. Now, what it basically does is you have a specific message with an address, and it has its own sender, and you are changing the value of the message dot sender to 1000 ether. So so the sender will have 1000 ether in their own value. Basically, the sender is associated the values 1000 ether. Now you can see how every single key is given a specific value. Now, this certain address will be given 500 ether. This is how you are able to initialize the value of different mappings that you are, defining initially. Now, we have seen how to initialize that in the constructor over here. And in this function, you can see how to change certain value. So over here, we have a function called deposit and public. Okay, sorry, we have table. Now we have balances message dot sender plus equals message dot value. Now, if you are familiar with writing code in different programming languages, not necessarily Solidity, you will be able to identify or correlate what this plus equals keyword means. Now, let's say the message dot sender, this key value has balance 0. So the value of message dot sender was 0 initially. And next time you want to, change it by 20 every single time. Every single time you call the function deposit table, what you basically do is you are able to change the balances of the sender to by 20 every single time or any value that you want. So once you are able to do this plus equals, you are just appending the value to the initial balances that are already there. So this is how you are able to change, this is just one example of what you can do to the value that is there in this key mapping, but there are other things like you can use general, like very simple plus and minus to change the value that is there. And there is another function to check the balance of the user. You just given the user as input and you can get the balances of user. So you are mentioning the key and then you get the values. This is just one example where you are able to use mapping in Solidity. But like whenever we are learning about this, we can just see that, this is just one basic example. You would think that it's not very important, but let's say you don't have this sort of data structure, you don't have a mapping, defined like this, then it'll be very difficult for you to make your own user defined stuff, and like it'll take almost extra 10 to 20 lines of code. Again, this will take extra gas fees, and not only gas fees, you will be like, let's say you want to change a lot of things, it'll make your code very unreadable. So using these types of data structures will help in making your code proper and very concise. Right. So I think right now we are going to different types of statements that we would go over in Solidity. So there are two main types of statements that you would come across. There are conditional statements, there are looping statements, and these are the two different, mostly these two types of statements are generally used. And if you can see this looping statement closely, you can see that we have used different types of loops. And if you are already familiar with loops, loops are like recurring, they are like you mention this I value, and until this I value satisfies this given value, it will be recurring, and the I value will be appended every single time. So you have different types of loops, like your for loop, your while, your do while, your etc. So all these types of looping statements are there, and if you can see them clearly, you can see that we have used the same type of statements here. Like this is one of the previous examples that I've given when I was going through Remix IDE. You can see that I have mentioned this loop, and I've given some certain like whenever this condition is being satisfied, this particular step will be done, or if this condition is being satisfied, this step will be done, or the loop will be exited, etc. This is an example of for loop. This is an example of while loop. So I was just saying that you can probably see the contrast that is there right here. So I have probably gone over looping statements before the conditional statements, but I'll just go over them quickly. So over here we have looping example. That is the name of the smart contract. And again, we have the constructor function we have, and then we are initializing this number array, and we have another function called calculate sum using for, and what it returns is it returns a u in 256, and you can see that you have defined this variable numbers. You are starting with sum equals 0, and you are changing it until the length of numbers is done, and you're appending, increasing the value of I by 1 every single time, and you are adding the sum of the array. Now, what it basically does is you have this array, you have the different elements in the array. In this for loop, every single time there is an element in the array, it will go over the element and it will add the value of the element to the variable sum. If you have initialized sum to be 0, it starts with 0, and then in the first iteration, let's say it goes to I equals 0. So the first value will be 1, sum will be 1 by the end of the first iteration, and then the second one is I equals 1. The second value will be 2. Numbers of I will be 2. Sum will be 1 plus 2, which is 3, and so on. So this is how a for loop will go. And again, like if you've written code in other languages, this is for code ease of writing code, and um, like basically writing concise code. Again, you know that writing loops will incur gas fees, but if necessary, we might have to do it. So in this case, it's very easy to actually write a for loop and just do the sum of the array this way. And you can also do the same thing, except instead of using the for keyword, instead of basically using a for loop, you are using a while loop. So here you have initialized I, you have the sum equals 0, and while there are elements in the array, you are appending the value of each of the element to the variable sum, and then you're basically returning the value of sum. And once you call any of these functions, you will be able to get the sum of the array. So this is how looping statements are done. And we haven't gone over conditional statements before. So this is another type of statement where here we have gone over, we are looping over the same thing. We are adding values to, a variable, etc. Whereas here we are checking for the value of a certain variable. And let's say you have different things to do for different values. You have one variable, and if the specific value is red, then you are asking the vehicles to stop. If the specific value is green, you are asking the value to go, etc. I'm just giving you an example. So if you want to check the value of a variable and do different functions or do different compile different statements depending on the value of the variable, you can use conditional statements over here. So here we have this contract conditional example. You are declaring an owner and discount rate of address and U 256 data types. And then you have another function over here, before which we have a constructor, and You're just initializing a few values. And then you see that, if message.sender equals owner, which we have already initialized over here, we are going to return the original price. Okay. Okay, so what it basically does is it tries to give a discount based on the ownership. So if it tries to get the address, and if it is the owner, it will not give you discount. Or if it's you are a high value purchaser, then it will give you a discount. And if you are a regular customer, again no discount. So it will get your address, it will check if you are the owner of the shop or whatever. And if you're not, it will just get the original price. And here you can see original price is greater than 100 ether. And this statement below will be executed only if this condition is being fulfilled. So only if original price is greater than 100 ether, the discount will be applied. That is, into discount rate, there is a specific discount rate, and like the specific discount rate will be applied, and the price will be reduced, and that price will be given. And if that is not the case, if you're just a regular customer, not a high value purchaser, then you'll just be given the original price. So these are just examples where you can use conditional statements. So I think I have gone over most of the different types of statements that you will see in Solidity, the data types, the different data types that you can make on your own that are constructs. I've given you 2 different exercises to do on your own. And I would like to ask if there's any questions for me, or if you wanted to, like know about something in detail again, or go over something again. If there's anything that I can do, or maybe we can take a break right now. Harsha, are you there?
Yeah, hello.
I
Okay, we'll wait for a few more minutes. If anyone has any doubts, you may put it in the chat box, or you can unmute your mic and ask.
or I would. There is like you don't even need to have a doubt if you just want to talk in general. Also, like maybe tell how the session was, or just give some tips or anything.
Shall we wrap the session then? So,
Yeah, I think we can. Yes.
okay, Darshana, it was a nice session. Thank you for the session. I hope it was really informative for the participants. And if there is any doubts, we'll be providing a live doubt session if possible. You can ask the doubts then, or if you want, you can ask the doubts right here or in the WhatsApp group. So that's it. We are winding up the session.
Thank you.
Thank you
Thank
all.
you. Thank you. Thank you.
Thank you all for joining. Yeah. Thank you, Darshana.
Thank you.
Good night.
Have a nice day. Have a nice day.